When you ask people what edge compute is, you get a range of answers. Cloud compute and DevOps with devices and sensors, the semiconductors outside the data center, including connectivity, AI, and a security strategy. It's a stew of technologies that's powering our vehicles, our buildings, our factories, and more. It's also filled with fascinating people that are passionate about their tech, their story, and their world. I'm your host, Pete Bernard, and the EDGECELSIOR show makes sense of what edge compute is, who's doing it, and how it can transform your business and you. So let's get started. But this sounds good. Trust me, I've had some folks with the AirPods on and shouting in their empty office, and it doesn't sound good. It's like, are you in a men's room or something? Or is it like a But yeah, no, it sounds good. Cool. Well, thanks for joining me. I guess we'll kind of just get started. One of the things I always forget to do is introduce the guest. I usually just start talking, and then like a half hour into it, realize no one's been introduced. So maybe we should start with Dave McCarthy, and you sort of give us a little bit of who is Dave McCarthy, for those that don't already know who you are, and kind of how did you get from here to there, or from there to here, I guess, technically.
Yeah, I think that's a good place to start. So,
sure.
Usually I start off by saying that, I've been in the IT industry in some form or fashion for about 25 years. Mm-hmm. But in that time, I've worn a bunch of different hats. I mean, I started, straight out of college, just as an IT practitioner. I was a system administrator, network engineer, did a lot of racking and stacking of servers,
right.
Kind of lived that whole life and kind of worked my way up into, management of large IT organizations. And I guess that was my first act. Somewhere along the way, I picked up a desire to not just be somebody that sort of, buys and deploys and uses all this technology, but felt like I was in a good position to help guide product strategy and do market messaging. And so I kind of went into Act 2, which was all around a bunch of different product roles. And there specifically is where I had a lot of focus on embedded software and mobile devices, and kind of where the edge computing thing comes into play. And then now, in my third act, I am a industry analyst. So it's kind of an interesting thing in the fact that instead of kind of looking at it from a single company point of view, now I get this opportunity to see what all the different companies are doing and what some of the problem spaces are for customers that are trying to solve problems. And it's and it all leverages, by the way, all that stuff I did in terms of walking in the shoes and designing products to say, like, hey, what advice would you give somebody if they were in those same situations? So,
right.
So yeah, so right now I'm working as a research vice president at IDC, and it's been a great opportunity to both look at kind of infrastructure in general, but that whole kind of edge to cloud continuum.
Right. Yeah, no, it's that sounds pretty cool. By the way, I noticed on your LinkedIn you went to Seton Hall. Are you from New Jersey originally?
Yeah, I was originally born in New York City, so my family was from the Bronx. And then we moved to Westchester County, and then eventually New Jersey. So yeah, I did my undergraduate at Seton Hall.
Oh, cool. Yeah, I'm from New Jersey as well. So I have a sensitivity to seeing people's backgrounds that might be from New Jersey. So I saw that. I also noticed you had under your, and this is going way back here, Seton Hall, you were involved in the pirate radio station.
Yeah, that was a lot of fun. In fact, I guess if I could have had a second career, it might have been in radio or something like that. I mean, I enjoyed.
You have a good voice for radio. I mean, I think I could hear you on radio.
Yeah, I mean, I enjoyed it all. I mean, of course, I looked at what my peers were doing, and they're like, "Hey, I can make like $15,000 a year out of college doing radio somewhere in the Midwest." Or there was the technical careers that were kind of calling my name, and so I went that way.
Yeah, I was on I went to Boston University, and I was a DJ, whatever they call it, on the student radio station there. I had a very late night slot. I don't know, it was like, 10 till 2 in the morning or something like that. I'm not sure anyone was listening to me actually, but it was fun. It was fun to
that was
spin some
unique
Pink Floyd albums,
Yeah, that was the unique part of WSOU and like where it was is because we had like our radio tower reached into New York City and all the way down to the Jersey Shore, so we had a pretty good coverage area in terms of like people that could hear it. So
cool. No, that's good. Yeah, no. So anyway, moving forward from that, I thought that was interesting. It's always interesting to see sort of like the deep background from folks and sort of what their journey has been. We all have journeys, and so it's always interesting to see that. So you've been with IDC for a while. So yeah, this whole space that you're in, I mean, I'm a little biased because I love the whole edge computing space myself. So, but like what's kind of the hot discussions these days around cloud computing and edge computing, or just the cloud stuff as well? I noticed that you do a lot of overviews and analysis of like AWS and Azure and a bunch of other folks. But is there like other than I guess generative AI, maybe we can not talk about AI for 5 minutes, but like, what is the hot topic these days when you get into these briefings? What is the hot question?
Well, so I will respect let's put the generative AI on the side, but to be honest, right, it's everywhere.
Yeah.
But I would say, but before that, let's just say, 6 months ago or 9 months ago, before that really kind of stole everybody's attention, it's really been around this idea of moving from like centralized to decentralized systems. I mean, the concept isn't new, right? And this is kind of where edge computing became kind of interesting again. Everybody always talks about the pendulum swing, right? I mean, you can go back in time, right? It was all mainframe centralized, and then it was all client server, and then web kind of brought it back in again. And, ultimately, what I'm seeing is people with a desire. I mean, of course, they're always trying to solve a business problem. And unfortunately, I feel like a lot of times in the industry, when you have a company that's strong in a particular area, like cloud, then, they're going to tell you that anything and everything that you want to do will work great in the cloud.
Right.
That's kind of course they're going to do that because that's what they're there to sell. And, it took companies it took cloud providers a while. I mean, some quicker than others to acknowledge that, hey, you know what? Not everything runs well in the cloud, or does it make sense to, right? So this idea of taking things then back out and putting them in different places. And so I think from an edge computing perspective, what's been interesting is just the diversity of different kind of deployment types, because we talk about it very like singularly, like, hey, there's a cloud and there is an edge. But we've learned that, there's things within telco, there's things on-prem, there's embedded devices, there's a whole spectrum of things. And ultimately, like, people experimenting and trying to decide like where to best to put a particular workload, without pigeonholing yourself into thinking it has to be in one place or the other. Like that's one thing that I've seen a lot of interest in.
Yeah, I was going to say, I think people are realizing that it's sort of like, I think in the UK they say horses for courses, but it's sort of like the right solution for the right problem. And, one of the things also on the cloud side, as you know, is that coming from a hyperscaler provider myself, is that cloud is a fairly universal piece of hardware. It's kind of fixed hardware. You kind of know what it is. Once you get out into the edge and beyond the data center, the edge becomes very heterogeneous. And like you said, there is no one edge. There's lots of different edge kind of configurations and archetypes and architectures and horsepower, and the network connection is going to be plus or minus. So it starts to get a little more tricky to deploy reliable solutions when you have sort of a fixed, maybe a fixed cloud hardware, but the edge hardware can be pretty variable.
Yeah, for sure, right? I mean, that's the world would be a really easy place if everything could just be, homogenized into a cloud data center. But you're absolutely right. I mean, and it happens in multiple layers, right? I mean, you look at it from a hardware perspective. There's all the different hardware platforms out there, especially as you get into these like legacy OT environments, right? So you have hardware standard differences, you've got software standard differences, even things like communication protocols and data formats. Like everything can feel like a snowflake. And I think that's the major challenge that people are trying to solve today is how do I scale these things when I know I've got kind of on one side all of this heterogeneous kind of environments, but yet I'm trying to apply like a consistent way of managing it. I don't know that anybody's fully solved that problem, but you're starting to see some aspects where that's gotten better.
Yeah, for sure. It's like people are kind of solutionizing a little bit and going up the stack because there's just too many pieces and parts, and too many different ways of putting stuff together to solve problems that, at the end of the day, every business has a problem they need to solve. That's why they're doing this stuff. And, the solution needs to fit inside of sort of an ROI framework. And as much as we geek out over the science experiments and the POCs, at the end of the day, the business is like, hey, I have a budget. I have to solve this problem. I don't want to sort of fart around with a bunch of test tubes and chemicals. I just want I want the solution. So, that's one of I guess the challenge and the opportunity. A lot of companies are really going to be making lots of money solving those problems by putting these pieces together. So, and I think these days there's more pieces than ever. Like you said, the edge capabilities are really accelerating with new semiconductor platforms and better networks and better workload orchestration and all this other good stuff. Like people are really investing on improving the kind of capabilities of the edge. And so, you're seeing a lot of companies maybe thinking about how do I run some of it nearby or on-prem or in the parking lot or in the hyperscaler. And so I think that's kind of ushering in a whole new way of thinking about not pendulum swinging necessarily, but, just kind of moderating and mitigating all edge or all cloud and all that stuff. So it's kind of an interesting time to think about that.
Yeah, I mean, I think part of it is just because, we're always chasing the bottleneck, and sometimes the bottleneck is like compute power. Sometimes the bottleneck is the network. Sometimes the bottleneck is just, how much space you have to store data in your device and stuff. Yeah. And so, and that's why I think, it'll never be, anytime somebody feels like they've cracked the code, things change, right? The world continues to change. And so I think from an edge perspective, even more so than in cloud, we need to be kind of looking at today's problem, but then also like what's coming down the road, because you'll need to be able to plan for that. And it'll look probably a little bit different a couple of years from now than it looks today.
Yeah, no, I like that. There's always going to be a bottleneck somewhere. So, just as soon as you fix one, there's another one. I was going to ask you about, I was reading about CoreWeave the other day. I don't know if you've analyzed them too much, but this idea of a kind of a GPU-centric or AI-centric cloud. It almost feels like, as silicon has sort of become specialized with CPUs and GPUs and IPUs and NPUs, it's almost like we're starting to see clouds themselves become more specialized for more specialized workloads, which I think is the idea behind CoreWeave, right? It's really an AI-centric cloud powered by NVIDIA, silicon. And do you see that? Like, where do you see like the CoreWeaves of the world relative to the AWSs and the Azures?
Yeah, so I'm not familiar with them completely, but I am familiar with the idea. And there's a few different concepts that are in there. I mean, one is the fact that, Intel for the longest time tried to convince everybody that all you need is a CPU. And if you need more capabilities, we'll just pack it into the CPU.
Just get a faster one, right?
Yeah, or, and they've done some innovative stuff. I mean, don't get me wrong. I'm a fan of Intel.
Yeah.
And even they realized, right, like they've branched out, because I think, all these companies that are kind of dominant in their market, I mean, they have a certain resistance to change because they know what works for them and what's been successful. And so, it always takes some other company to kind of come in and sort of disrupt things a little bit for the bigger entrenched ones to say, well, hey, maybe that's a big enough of a trend that I should sort of jump onto it. So one of this is what I think you touched on, which is, CPUs by themselves will not be able to handle all of the sort of complexity of the applications that people are building today. So you have all of these other sort of co-processor kind of variants. And of course, the one that's really captured people's mind are the GPUs for what they're doing with the AI side. But you mentioned that sort of IPU, or like NVIDIA would call it the DPU. But, again, same idea, right? Like you want to offload, like the CPU is good for certain operations and that's great. But ultimately you end up having sort of a collection of specialized processors, I guess, that are for different things. And so I think that's one thing, which is just this acknowledgement that, back to the right tool for the job, there's going to be different silicon types for different parts of the solution. And then the second part is, what we're seeing in cloud more and more is this idea of like composability of the infrastructure, or being able to maybe decompose the infrastructure into its elements such that, you're not just sort of scaling things linearly, but you can say, well, I can, sort of individually kind of control the components that are in there. And so for something like a GPU or AI centric cloud, it does make sense to me, because you're going to find certain workloads that are really kind of tuned for that type of environment.
Yeah.
So and you see the big cloud providers doing the same thing, right? So there's, it's a couple of ways to think about it, right? I mean, the big clouds are looking at ways of building specialization, but these smaller providers are, again, kind of like what I was saying earlier, they're sort of creating that disruptive force to make it real.
Yeah, no, I think it's fascinating, and we'll see, like, just sort of like as people are decomposing their workloads to run, some more in the cloud, some more in the near edge of the network edge, some on-prem, on the far edge. And I think we might see people orchestrating workloads to run across different clouds, depending on what the workload is, right? So if it's more of a FinOps type process, that might run on Azure, and then there's a heavy duty AI that could be running on CoreWeave, and then all that could be sort of orchestrated together across multiple clouds. I don't know. It feels like that's sort of like a horizontal, maybe a horizontal deconstruction as opposed to an edge to cloud deconstruction of workloads. I'm not sure if that makes things more complicated or makes them better, but it's interesting to see. It's interesting to see some innovation there.
Well, yeah, I mean, and that's, I think a lot of what we're seeing today with everything we just discussed is happening kind of on that cloud side. So then the question does become, so when you extend that out into the field, how much of it comes with you and how much of it doesn't?
Yeah.
If you're talking about really small devices, chances are, especially small devices that, if you get back into the IoT world, right, like battery powered devices, I doubt you're going to see a GPU associated with a battery powered device, at least not in any significant way in the short term.
Right.
And so, it does sort of depend back to those like layers of edge. So if you are kind of looking at something like a metro deployment location, within a city as opposed to a big hyperscale region, absolutely. Like that to me fits, part of the definition of edge. And, we are seeing some interesting configurations in there. But then again, like I said, it has to somewhat scale down to smaller sort of form factors. And I think the jury's still out as to how some of these architectures will mature. But the one thing that I'm fairly certain of is that there isn't just a single edge. I think we'll see more of like what I might refer to as kind of like a multi-tiered kind of scenario where at different points in the architecture, you have like right-sized kind of aggregation and intelligence. And eventually it all rolls up to some big cloud thing because there's going to be somebody in the back office that wants to see, that wants to see the big dashboard that says, hey, how is everything running?
And you want to store the data over time and all that good stuff. And
for sure.
And look at it. No, I agree with you. I think though, one of the interesting things, I don't know if you've followed getting down to the tiny edge, some of the work from the TinyML Foundation and like Aleph Semiconductor and stuff. So like Aleph is interesting because there's not a GPU on there, but they do have the ARM M55 core on there. So they're doing like this kind of AI model acceleration on like Cortex M, like MCU based silicon. So you can do some anomaly detection and other, image recognition, is the store shelf empty and stuff like that. So you can run the AI models today on battery powered silicon. It's just a matter of making sure it's the right model with the right use case. And as long as the battery lasts a couple of years, could still work. But I think we'll see AI acceleration across everything from the tiny edge to the Cortex A. Obviously, we have it there already, and then to the heavy edge. And who knows? These kind of more vertical clouds start up. I was looking at a company called Crusoe. I don't know if you've heard of them. A friend of mine just pinged me on them last night. They run a cloud service that apparently, and I haven't actually dug into this too much, so you can put your workloads on their cloud. Their cloud is powered by like excess energy. So you're talking about sort of sustainable cloud operations. So what they claim is that they capture like these gas flares and the energy from that, and they somehow, capture and transmit that and power these kind of remote data centers off of this excess energy from an excess energy grid of some sort. So I thought that was kind of interesting. It feels a little niche, but the whole topic of sort of, environmental and sustainable resources and computing obviously is a huge topic we could talk about. But Crusoe specifically, I was like, interesting. Like, okay, getting the gas flares and turning that into electricity is kind of unique. So I don't know. We'll see. Yeah.
Well, I think that's one of the biggest problems that these companies are going to eventually have to solve for. I mean, if you talk to a major cloud provider today and you ask them about like their build outs into like other countries and regions, one of the biggest challenges they have is finding enough like renewable energy in some of these places. Yeah. And that drives some of or inhibits some of their expansion. And, what's interesting is, when it comes to the edge computing side of things, like, I know companies like Schneider Electric are working on like how to extend some of those benefits to smaller edge footprints. But the reality is for a lot of companies, like you focus your attention where the big energy use is. And so like right now, a lot of the attention is on big data centers. It's not so much at what's happening at the edge. But then when you think about how many edge locations and all the, like it's a brewing problem that I guess hopefully like some of the innovation that happens in the big data center will kind of find its way out to the edge. But it doesn't seem to be for a lot of companies, it's not the biggest problem they're trying to solve. It's like a roadmap issue.
Yeah. And I think there's a lot of, greenwashing is kind of a strong term, but I think people are trying to be good citizens and make sure they try to be as close to carbon neutral as possible. And so it's easier to do that if you just put all your stuff on a big hyperscaler that has a good, carbon neutral program. It's a little harder to do that if you have a lot of heterogeneous pieces and parts that you really aren't even measuring or can measure, like the power consumption on. So you can't really make any claims about carbon neutrality for anything really outside the data center at this point. But I think it's coming. At some point, there'll be some intelligence around power usage, and you'll be able to look across the whole taxonomy of your system and kind of understand maybe the power in and where it's coming from and the power going out. I mean, we're probably pretty far away from that, but ultimately, I think people want to be held accountable for the sustainability of their solutions, whether they're completely edge focused or completely cloud focused or whatever. I just think we're probably just not there yet in terms of being able to measure that stuff outside of a data center.
Now, what I do think is interesting is that there's like when you get out to the edge, you do have smaller systems. I mean, battery might be part of how their power is supplied, but this is also a place where you see some interesting examples of like renewable energy. So like I saw, I think Lenovo talking about one of their smaller servers being powered at some sort of like remote facility through solar, and battery was there as kind of a backup. And like they had designed the infrastructure to be efficient enough such that would work. So they didn't necessarily even need, connection to a power grid. Because again, when you talk about some of these edge locations, there's what I would refer to as kind of like IT friendly edge locations. Like not everything needs to be ruggedized, and just because it's small and remote doesn't mean it's harsh. But then there's all these other examples where it's just like, hey, I'm out in the middle of an oil field somewhere, or I'm out, in the middle of a forest, or I'm doing smart agriculture, and there isn't really just power out there or communications in the way that we expect it. And this is where I feel like, some of these alternative power sources come into play. I think this is where some of the alternative networking, like private 5G, comes into play, because these are just kind of like off the beaten path kind of locations.
Right. Or like LPWA or kind of super low power networks. Also, like you're looking at folks like Qualcomm who talk a lot about going back to generative AI, talk about doing like a lot of AI workloads on the edge using very low power silicon. I mean, that's their specialty, is low power connected silicon, where you can run lots of AI vision workloads and things like that with battery powered or solar powered, units that are just out there indefinitely. And you don't need to crunch a big Azure Stack Edge box or something like that needs some DC or something like that. But, and then there's also this thing called LDES. I don't know if you're familiar with that, the long duration energy storage. So that's like the kind of big batteries that can store power for over 10 hours. And it's kind of a nascent area, but in a lot of these situations, you can take a renewables like a wind or solar, and you can feed into an LDES, and then the LDES, even though maybe it's not windy or it's not sunny or whatever, the LDES will provide sort of consistent power to that remote location over time. So you could have a data center that has an LDES next to it and has renewables powering it, et cetera. So yeah, it's really interesting. I mean, some of this stuff's a little bit kind of years away, but there's a lot of money being put into it. And I think ultimately, I think there'll be a lot more awareness and publicity around the kind of sustainability of some of this compute solutions out there. Because like I was saying, like when Leonard was saying, don't ask ChatGPT what 1 + 1 is. I mean, you're burning a whole set of trees just to answer that question. So it's not a really good use of resources. And I don't think people really realize that. They don't realize that it's not free, to do this kind of stuff. It actually costs resources to do it. So yeah, I think that's an interesting challenge. Maybe that's the next bottleneck, is the sustainability footprint of your solution, is to make sure that that sort of complies with your local regulations or your corporate governance, right? That's going to be yet another thing to solve for with these kinds of solutions. So keeps everyone in business for a long time, I guess.
Yeah, I completely agree.
Well, yeah, no, it's fascinating. Actually, well, when we talk about this, like, give us an idea, like, kind of maybe not day in the life, but I've talked to some of these folks that are involved in a lot of the industry analyst stuff, and it seems like the amount of sort of engagement and travel is like really tremendous. And there's just so much going on. I mean, if you go onto LinkedIn, there's probably like a dozen different things going on a daily basis in 12 different cities around the world. How do you prioritize your time and what how do you allocate your time and be able to task switch without like kind of thrashing?
Yeah, well, if there was one good thing about the pandemic, it was just the fact that everything was a virtual event. So it was possible to be in more than one place at one time if you had multiple screens, and those obviously doesn't exist today.
Right.
And last year I felt like was kind of a transition year, and this year for sure. If I wanted to, I could be on the road pretty much every week. But then I wouldn't get any work done. So, I think it's for me personally, I mean, I get to take a pretty broad view of the market. So when I think of like the types of companies that I speak with, I mean, sometimes, it is the cloud providers. And so I try to make sure that I'm at the important cloud provider events, or it's with, software companies like VMware and Red Hat, and they have their events. And then there's like the OEMs like Dell and HPE and others. And so, so for me, one of the things that I always thought was important in my career in general, and I think it's incredibly important as an analyst, is to try to be as well-rounded as you can, and, get different opinions and perspectives, because ultimately when you think about these kinds of solutions, usually it's not one company solving the problem. It's usually multiple companies working in coordination to make this happen. And if you can't connect the dots yourself, then people who are customers of mine won't find my information very useful. So, there's no magic bullet in terms of prioritization. I try to get enough face time with all of the major categories that I think are relevant in this kind of cloud to edge infrastructure continuum to make sure that I'm on top of things that are going on. But then I'll also tell you, like, the other thing that I have a sort of a soft spot for are startups. Right. Because, I think, these big companies are, they're the big aircraft carriers moving around, doing the things, and they have huge influence and ability to do it. But it's the startup community that often has, the most interesting innovation, and they're the ones, making the crazy bets. And to be honest, some of them are crazy, right? Like I've heard pitches of companies that have a really interesting perspective, and I'm like, yeah, that sounds really cool, but I can't imagine it will ever get commercialized. But then, you find ones that really have found that white space that exists out there. And, and those are the ones that, typically, you can tell when I talk to companies year over year, like which ones give you the same pitch year over year, which means like not much has happened. And then ones where you talk to and you're like, holy cow, you accomplished all of that in a year. Imagine what you'll do, in another year. And so it's pretty easy to see like which ones are sort of coasting and which ones are really like gaining some traction.
Right. Yeah, no, totally. I got involved in an organization, a company called Conduit Venture Labs. So for listeners, you can look them up. But they do kind of incubation of a lot of IoT startups. And especially, I think, in the IoT and the edge space, there's a lot of these, they're doing smart ag, or they're doing smart power, or they're doing something just very unique and innovative. And like you said, it's hard for the larger companies with all the bets and investments to maybe move that quickly. So yeah, it's great to have a robust kind of startup community there. And the other thing, totally agree with you. It's like I always say, the edge is a team sport. When I talk with companies, thing I ask them is like, whose team are you on? And who are the other teammates that you're taking a dependency on to drive your business? And you have to be super clear on who you can leverage and take dependencies on, and vice versa. Because if you're on the right team with some great teammates, as you know, good things can happen. So definitely the edge is a place where there's never one company that comes in and solves the problem. It's always a consortium or a collection of folks. So yeah, you're right. Sort of understanding like for me, it's like not just around the semiconductors or the devices or the networks. It's all the stuff and the software and how it all comes together that really is the story. And so, yeah, I can imagine. I guess I'm making an argument that your job is even more difficult because you have to sort of understand all these different aspects. But yeah, I think that's what makes it fascinating and a great opportunity too for startups to come into the space. If you can pair up with and get on the right team and have the right teammates, even as a startup, you can leverage some pretty experienced channels and technology and make some big inroads and land some big customers. So it's pretty cool.
Yeah, and it's a critical decision for a small company because you typically, like every small company, have limited resources.
Yeah.
And so while you would love to be able to be everybody's friend, you can either do that, sort of poorly with lots of people, or you could do it really well with one, right? And my advice would typically be, to hitch your wagon to somebody that's sort of understands your value proposition and can help you do that. Because, when I think about some of the, even today, like things that I hear about IoT, right? Like I'm sure we've all seen it somewhere on LinkedIn or somewhere where somebody posts a headline like IoT is dead or, IoT was like a big failure or something like that. And I always laugh because I look around and I'm like, everywhere I look, there's smart connected devices generating data that's being used for some purpose. Like that's IoT. Like I think what's happened is IoT has become almost invisible so much now that it's been like integrated in that people don't think of it separately anymore.
Right.
So
Yeah.
wonder,
It's been
like,
mainstreamed as part of a solution as opposed to a thing in and of itself. Yeah. I totally agree with that. Yeah.
And I think that that's true, like for a lot of technologies. I mean, I think that's the, where we are with some of this AI conversation right now. Like we're having to put so much emphasis on it because it's kind of new and different. And even though it's existed for a really long time, it hasn't really been applied so ubiquitously all over the place. And that's part of the, the storyline that I'll often tell people when they say, well, I did buy into the whole IoT wave and I invested in all this stuff. So I have new data points. And then, but they usually have that hangover of, I didn't really get my ROI out of the solution. Like what happened,
Right.
And, just to tie this back to Edge, I mean, I think the failure that some of those companies had is, well, could usually fall into two reasons. One is they may have just not actually had a strong business problem that they were trying to solve that they could work backwards from. And they just kind of went off and did it because it seemed like the right thing to do. And that's like a rudderless ship, you'll never get to port, that way.
Right.
But if it wasn't for that, even if they knew what they were going to do, it was this issue of like trying to tie together this data in the field with the intelligence in the cloud. And there was just this huge chasm between those two places that even if they could make something work in a proof of concept, they could very rarely like scale it to a point that it was useful. Right. And to me, this is where like the edge computing idea, even though like, we put so much effort into saying it's this great new edge thing, but to me, it's an extension of things we've already done. It's like, instead of taking all the data and moving it to where the processing is, if we could take some of that processing and move it to where the data is, oh my goodness. Now what started off as a very disjointed, kind of process is like, wow, I can do a closed loop system on-prem that does everything from collect the data to understand the data to implement action. And then, of course, I'm going to report back what I did to some centralized source. Like it was the missing piece, I think, that that stymied some of those, early projects. And so if you're embarking on this now and you can take advantage of all these, then I feel like a lot of the inhibitors have been either minimized or eliminated.
Yeah, no, I definitely agree with that. I think it's sort of an evolution of the same concept, but the tech is better, the networks are better, the chips are better, the software is better. And so, it's there's a lot of new ways to sort of solve the problems that people have been trying to solve for a long time. And you're right, it gets kind of mainstreamed and it's not as glamorous because it's just sort of part of what you do, and I think with AI, we'll see that as well. We're already starting to see that in a number of products where it's just the way the product works and, becomes sort of an expected outcome as opposed to some, science fiction cool thing. So, but yeah, no, it's that's the, like you said, there's always another bottleneck and we'll find it, I'm sure. Let me ask you, Dave, if you have any closing thoughts or any words of wisdom that you would want to impart upon us in the edge compute world from your perspective?
Well, we tried to stay away from really spending too much time on the AI thing, but at IDC, you know, we're keeping an eye on it, and in fact, we're rallying around this term, you know, AI, you know, everywhere. And so while it's going to start with big systems in the cloud, it's going to find itself, as we've already seen, you know, out in these edge locations. And really the challenge will just be back to this centralized versus distributed. You need a distributed infrastructure. You also need a distributed data plane, and you're going to need these distributed applications that kind of understand that. And so, you know, so to me, I'm excited to look out over the next couple of years and see how these things continue to mature, and as all those technologies continue to get better, and more importantly, like people understand them better, and they've made a few of the mistakes, right? Touch the hot stove. Okay, I won't do that again. Yeah. But you know, find something that works and say, hey, let's do more of that. I think we're going to continue to see, you know, more and more, you know, great examples of it's not just a cool technology thing, but it's actually solving real business problems and creating real business value. And ultimately, that's what we're here for, right? That's exactly. That's what gets at least that's what gets me excited, is that kind of like, hey, how do the worlds of business and technology collide?
Yeah, no, exactly. And you know, seeing AI as sort of a supercharger or providing superpowers, you know, to solutions is kind of exciting when we see that. So cool. Well, Dave, thanks again for taking the time. I appreciate it. And I'm sure I'll see you around.
All right, Pete. Thanks again.
Cool. All right, take care. Thanks for joining us today on the EDGECELSIOR show. Please subscribe and stay tuned for more, and check us out online about how you can scale your edge compute business.